All right, this is part 2 of reading chapter 3 from the IBM System 370 Principles of Operations. Let's see how far we can get in this video. Last time where we left off was byte-oriented operand facility. So that section begins at the top of page 30. The byte-oriented operand facility is standard on System 370. This facility permits storage operands of mostly unprivileged instructions to appear on any byte boundary. The facility does not pertain to instruction addresses or to the operands for compare and swap and compare double and swap. Instructions must appear on 2 byte integral boundaries. The rightmost bit of a branch address must be 0, and the instruction execute must designate the target instruction at an even byte address. Compare and swap must designate a 4-byte integral boundary, and compare double and swap must designate an 8-byte integral boundary. Their programming note says for fixed field length operations, with field lengths that are a power of 2, significant performance degradation is possible when storage operands are not positioned at addresses that are integral multiples of the operand length. To improve performance, frequently used storage operands should be aligned on integral boundaries. The next section is titled Address Types. For purposes of addressing main storage, 3 basic types of addresses are recognized: absolute, real, and virtual. The addresses are distinguished on the basis of the transformations that are applied to the address during a storage access. Address translation converts virtual to real, and prefixing converts real to absolute. In addition to the 3 basic address types, additional types are defined which are treated as one or another of the 3 basic types, depending on the instruction in the current mode. Alright, our next section is titled Absolute Address. This is the address assigned to a main storage location. An absolute address is used for a storage access without any transformations performed on it. All CPUs and channels in the configuration refer to a shared main storage location by using the same absolute address. Available main storage is usually assigned contiguous absolute addresses starting at 0, and the addresses are always assigned in complete 2K byte blocks on integral boundaries. When either test block or the storage key 4K byte block facility is installed, storage is assigned in complete 4K byte blocks on integral boundaries. An exception is recognized when an attempt is made to use an absolute address in a block which has not been assigned to physical locations. On some models, storage reconfiguration controls may be provided which permit the operator to change the correspondence between absolute addresses and physical locations. However, at any one time, a physical location is not associated with more than one absolute address. Storage consisting of byte locations sequenced according to their absolute addresses is referred to as absolute storage. So a real address identifies a location in real storage. When a real address is used for an access to main storage, it is converted by means of prefixing to an absolute address. At any instant, there is one real address to absolute address mapping for each CPU in the configuration. When a real address is used by a CPU to access main storage, it is converted to an absolute address by prefixing. The particular transformation is defined by the value in the prefix register for the CPU. Storage consisting of byte locations sequenced according to their real addresses is referred to as real storage. A virtual address identifies a location in virtual storage. When a virtual address is used for an access to main storage, it is translated by means of dynamic address translation to a real address, which is then further converted by prefixing to an absolute address. A primary virtual address is a virtual address which is to be translated by means of the primary segment table designation. When DAS is not installed, all logical addresses are treated as primary virtual addresses when DAT is on. When DAS is installed, logical addresses and instruction addresses are treated as primary virtual addresses. When in the primary space mode, the first operand address of move to primary and the second operand address of move to secondary are always treated as primary virtual addresses. A secondary virtual address is a virtual address which is to be translated by means of the secondary segment table designation. When DAS is not installed, secondary virtual addresses do not occur. When DAS is installed, logical addresses are treated as secondary virtual addresses when in the secondary space mode. The second operand address of move to primary and the first operand address of move to secondary are always treated as secondary virtual addresses. Logical address, except where otherwise specified, the storage operand addresses for most instructions are logical addresses. I'm going to jump down to the instruction address section. It says addresses used to fetch instructions from storage are called instruction addresses. They have a note here: when the CPU is in the secondary space mode, it is unpredictable whether instructions, including the target of execute, are fetched from the primary address space or the secondary address space. For details, see the section Translation Modes and the associated programming notes under the section Dynamic Address Translation in this chapter. Okay, the very last paragraph I'll read is titled Effective Address. In some situations, it is convenient to use the term effective address. An effective address is the address which results from address arithmetic before address translation. Address arithmetic is the addition of the base and displacement, or of the base, index, and displacement. Okay, that's it for this video. In the next one, still reading chapter 3, we'll begin with the storage key section.